We also make a laser we call it AFX, and so it's a beam shaping laser. In a standard laser, we have what's called a Gaussian beam, right? So your typical bell shape, that's the intensity profile that's going to hit a substrate. And in the case of additive manufacturing, that's the intensity profile that hits a powder bed. And the thing about that Gaussian distribution, intensity distribution, is that in order to get the intensity that you need at the sides to do complete melting of material, you need to really increase the intensity at the center. And that means that you're going to be over boiling your materials, and you're also going to be hitting that powder bed with an intensity and force that is much beyond what that material actually wants to accept. And it has a whole lot of impacts and ramifications for the part that you're making. So what beam shaping does is it delivers the beam in a non-Gaussian mode, which is we use rings. So what we've found is if you can deliver the laser in a ring shape, what that means is that your intensity is much flatter, and then as that intensity translates to the heat input, it's completely flat. And so that makes for a much more stable melting process. It means you can get a lot more power and heat into the melt pool without disturbing it. It leads to a lot less soot and spatter popping up out of that melt pool that you tend to get with a Gaussian beam. It also means that you can greatly increase your processing window. So because you can get more heat in a much more stable fashion, you can go a lot higher in power. And that means with high power becomes higher speeds. Higher speeds means higher build rates. Higher build rates means a lower cost part at the end of the day. That's really how that translates